Imagine a cloud of tiny computers, each smaller than a grain of sand, floating through the air. These are not science fiction, they are called smart dust. Smart dust is a collection of miniature sensors, each packed with technology to sense, process, and communicate information. They can be scattered almost anywhere, from forests to hospital rooms, gathering data in ways we never thought possible. Why does smart dust matter? The world is becoming more connected every day. Smart dust could be the next step, making it possible to monitor everything, everywhere, all at once. This could help us solve big problems, like pollution or health emergencies, by giving us real-time data. What makes smart dust special is its size and scale. Traditional sensors are big and need wires or batteries, but smart dust is tiny, sometimes just a few millimeters wide, and can work without direct human control. This opens up possibilities that were impossible before. We'll look at the technology, the uses, the challenges, and where it all started. Let's dive in. At the heart of smart dust is something called MEMS, or microelectromechanical systems. MEMS are tiny machines, built on the same kind of silicon chips that power your smartphone. Each smart dust mote contains a MEMS sensor, a microprocessor, a wireless transmitter, and a power source. All of this fits into a package so small, you could fit hundreds on a single coin. These sensors can measure things like temperature, light, pressure, chemicals, or even movement. The microprocessor acts like a tiny brain, deciding what data to collect and when. The wireless transmitter sends that data back to a receiver, which could be a computer, a phone, or a special network. What makes smart dust unique is its ability to work as a network. Each mote can talk to its neighbors, passing messages along until they reach a central hub. This is called a mesh network, allowing data to hop from one mote to another. Engineers have to solve problems like making the motes tough enough for harsh environments and keeping them powered for a long time. But as technology improves, smart dust is getting smaller, cheaper, and more powerful. Smart dust has the potential to change many industries. In the environment, scientists could scatter smart dust in forests to detect wildfires early. The motes could sense heat and smoke, then send alerts before the fire spreads. In cities, smart dust could monitor air quality on every street, helping to fight pollution and keep people healthy. Factories and farms could use smart dust to track machines and crops. Imagine a factory where every piece of equipment has a smart dust mote attached, sending warnings before breakdowns happen. On farms, motes could measure soil moisture, temperature, and nutrients, helping farmers grow more food with less waste. Hospitals could use smart dust to monitor patients without wires or bulky machines. Tiny motes could track heart rate, temperature, or even chemicals in the blood. This could help catch problems early and make care more comfortable for patients. Even the military is interested in smart dust for border security, vehicle tracking, or detecting dangerous chemicals. The possibilities are vast, but each use case comes with its own set of challenges. One of the coolest things about smart dust is how it talks to the outside world. Each mote has a tiny wireless transmitter, usually based on radio waves or sometimes even light. These transmitters aren't powerful, but they don't have to be. Since the motes are close together, they can send short messages to their neighbors, which then pass the message along. This method is called multi-hop communication. Instead of one big transmitter, each mote only needs to reach the next one, saving energy and making the network more reliable. If one mote fails, the others can still pass messages around it, like cars taking a detour. The data collected by smart dust can be sent in real time, or stored and sent later when a receiver is nearby. Some systems use special frequencies or even infrared light for security and to avoid interference. All this wireless communication has to be secure, so engineers use encryption and other tricks to keep the data safe. As smart dust spreads, keeping networks secure will be even more important. Power is a big challenge for smart dust. These tiny motes can't carry big batteries, so they use clever ways to get the energy they need. Some use micro batteries, tiny versions of the batteries in your watch or phone. Others use solar cells, like miniature solar panels that turn light into electricity. If the motes are outdoors or near a window, they can keep running almost forever. Some researchers are working on energy harvesting, getting power from vibrations, heat, or even radio waves in the air. Imagine a mote that charges itself just by shaking or being near a warm machine. Energy use is kept low by making the motes sleep when they're not needed. They only wake up to take a reading or send a message. This is called duty cycling, and it helps the battery last much longer. As technology gets better, new power sources may appear. Some scientists are even looking at ways to power motes using chemicals in the air or inside the human body. The race to find the perfect power source is still on, but progress is being made every year. With great power comes great responsibility. Smart dust could bring huge benefits, but it also raises big questions about privacy and ethics. If you can scatter sensors anywhere, who controls them? Who gets to see the data? Could someone use smart dust to spy on people without their knowledge? In cities, smart dust could help track pollution or traffic, but it could also be used to watch where people go or what they do. Some experts worry about surveillance creep, when technology meant for good ends up being used in ways we didn't expect. Laws and rules will need to keep up with the technology, to make sure people's rights are protected. With the right rules in place, we can get the benefits of smart dust without giving up our privacy. The idea of smart dust began in the 1990s. A scientist named Chris Pister at the University of California, Berkeley, first imagined tiny wireless sensors that could be scattered like dust. His team built some of the first prototypes, showing that it was possible to make computers this small and smart. Since then, the technology has come a long way. Advances in MEMS, batteries, and wireless chips have made smart dust smaller and cheaper. Today, companies and universities around the world are working on new ways to use smart dust in real life. Some projects are already being tested in factories, farms, and hospitals. Looking ahead, smart dust could become as common as Wi-Fi or GPS, helping us solve problems we can't even imagine yet. But it will also force us to think hard about how we use technology and how we protect our rights. If we use it wisely, smart dust could make our world safer, cleaner, and more connected.